So we want to take a look at the big ideas from this chapter. So the first one talks about flexible methods of computation and how they always involve decomposing and composing numbers. So that's basically taking apart and putting together numbers in a wide variety of ways. My philosophy is children need to be able to solve problems in the way that their brain works the best. Sometimes the standard algorithm is that way, other times it's not. But allowing children to be flexible, especially with multiplication and division, is very important. When they use different methods, those methods usually require strong understanding of commutative property, associative, and distributive properties. So make sure that you understand those, commutative being 2 add-ins or factors, associative being 3 add-ins or factors, and then distributive property, which is decomposing and then composing the pieces of the problem to put them back together. The rest of them, 3, 4, take a look at number 4. The standard algorithms are clever strategies for computing. That means the standard algorithms are like shortcuts, but you have to understand how it works before you do that standard algorithm. If the standard algorithm is the only thing that you're teaching, students will not have a good grasp of the actual concept because really that's a shortcut. All right, so let's move on and talk about multiplication. Some invented strategies for multiplication include repeated addition. You can see that on the left, 63 times 5. The student basically took 63 and added it 5 times. There are 2 ways to do that, as you see on that paper. Another way to do it is to use some sort of visual tens rods, ones blocks, or even drawing them. In this case, representing 6 times 34, so 6 groups of 34 things. Now the one down at the bottom that looks like a rectangle, we're going to be talking a little bit more about. But basically it's like distributive property, where we're going to divide 34 up into 30 plus 4, and then multiply 6 times 30, 6 times 4, and then add them. So 180 plus 24. Here are some more invented strategies that you can see. Students are taking 27 times 4 and basically using distributive property, 4 times 20, and then 4 times 7 and adding them together. The same thing with the other problems there on the left side. Now the one at the bottom, actually 46 times 3, what the student did was 46 times 2 in their head and then just added another 46 to it. So they doubled it and then added another 46. You can see on the right, they're actually breaking that up even more. 27 times 4 is 10 times 4 plus 10 times 4, and then 7 times 4. Down at the bottom, it looks like they're doing, let's see, oh, I see, 25 times 4 is 100, so 25 times 4 is 68. And then they did 2 times 8 equals 16 and not 7 times 8 because they're compensating for that 25. That's actually a very well-developed strategy, but I don't think a lot of kids are going to do it like that. With multiplication of multi-digit numbers, it's important to stress place value so that students understand that concept and can then figure out problems that have more digits. If you look at the problems on the right, these are invented strategies from students. And let's look at Kenneth's. The problem up above is there were 35 dog sleds. each sled was pulled by 12 dogs. How many dogs are there in all? So Kenneth actually took 3 times 35. He was breaking up the 12 because that was an easy number for him to break down. So first he started with 3 times 35 and got 105. Then he doubled that answer because that would give him 6 that he's multiplying by. Then he got 210. And then he doubled that answer because that would give him the 12 that he was originally going to multiply by, and he got 420. So he started with 3, doubled that answer, and he ended up multiplying by 12. He just broke it down, and the answer was 420. Now Nick, there at the bottom, took the 12 times 5, and he got 60. Then he did 12 times 3, which was 36. But he knew that the 3 was in the tens place, so he added a 0 to make 360. And then he just added 360 plus 60 equals 420. Now this particular method maps onto standard algorithms very well, but it's called an array. And the problem actually represents 72 times 36. So we break down those sections of tens and ones, and then we just use our fingers, and wherever they cross, that's where we're going to put an answer. So 70 times 30, well, I know 7 times 3 is 21, 2 zeros, 2,100. Then move across. 70 times 6, I know that 7 times 6 is 42, so that's 420. And then move down to the next box. 2 times 30, 60. And then 2 times 6, 12. Then all you do is add each of those partial products and you get the correct answer. This way, the students are not working with such large numbers and carrying things. They are actually working with numbers ending in 0, and that seems to work for them because it's more familiar. Some invented strategies for division are represented here. What you have to keep in mind in telling students when they invent their own strategies, that it's important that every group that you have in division is kept equal. So you have to partition the groups and make sure they each have their fair share, and then what's left over is your remainder. If you take the first example, 72 divided by 3, the first box represents just gathering those materials. The second box is trying to put these into 3 groups. Okay? Well, we realize that 3 of the groups have the same amount, but the 4th one does not. So let's take that 4th group and exchange it for the ones, then we can equally divide them into the 3 groups at the bottom. Problem B shows that very same thing, dividing them into 4 equal groups. Estimation is an important piece of multiplication and division because it allows the students to see if their answer is reasonable. Because multiplication and division can be complicated, students need to know if they are even in the right ballpark for getting their answer. And think about it. When we go to the store or we are doing something in real world, we don't often give the exact number unless you are measuring, like building a house or something like that. I don't usually give the exact number. If someone asks me, how much did you pay for that? I might say around $9 or around $24. I'm not going to say I paid $24.37. So we use a lot of estimation in real life. Teaching children how to estimate is very important. What's important to remember about multiplication and division is that people are going to think in different ways. Be sure to show your students all the different ways to multiply and divide, and let them choose which strategy works best for them.